Yes, ma'am. Okay, ma'am. Good afternoon, ma'am. Good afternoon, all of you. Today topic is my design of low power, high speed full adder circuit. Basically, the application of full adder. The full adder basically work as in many using arithmetic adder and many using a subtraction circuit. So we in the industry we demanding a low power consumption and high speed uh, adder. So we first of all discuss content what we contain in this PPT. Generally introduction, keyword and conventional full adder, and then full adder truth table, schematic of full adder, and the power value of full adder and proposed full adder using the XNOR and topology, and then summary. So first we'll discuss introduction. So basically full adder is a adder that three inputs and produce two outputs. So it see that you see that the three inputs A, B, C, and sum and C out. So that that is a conventional full adder. The power consumption is this adder is much more. So greatest challenges in our VLSI technology. So we reducing the power dissipation or a low power use. So we designing the such type of full adder so much does not much consume the much more power and reducing the delay. So we designing the such type of full adder. Second PPT is onward the keyword. So first of all, what we keyword use in this PPT: CMOS full adder we designing and the low power VLSI design and XNOT or XNOT topology and Tanner EDA tool. So basically Tanner EDA is a software tool. So we're designing the such type of full adder in the number of transistor we use in CMOS technology. We're reducing the number of transistor in the full adder. So basically, in third PPT, in fourth PPT is a conventional full adder. Full adder, we using two types of full adder, that is a statics and dynamics. Static full adder are the less power consumption than the dynamic, because the static full adder does not having a such type of gates, more number of gates, so that not must does not much using a more power, so it is less power. But in dynamic having a much more power required to the run the operation, and but it is a more reliable. But in dynamic full adder has a faster switching speed, full switching voltage, so it is a much more used in industry in dynamic full adder. So we reducing, but in the disadvantage dynamic full adder, but dynamic full disadvantage is large number of power consumption is more in dynamic full adder. So we reducing the power consumption by using the such type of the complexity circuit. So we general expression of the sum is A XNOR B XNOR C in, and the general expression of C out is A dot B plus C in A XOR B. And then we see the truth table of the full adder. So how we can sum and C out is come from the truth table by using a K-map and K-map method. So we can get out the sum method, sum expression and C out expression. So basically this is a truth table and this is a CMOS implementation of full adder. So you can see that CMOS implementation of full adder is 28 transistor we use. So that number of transistor is increases in this conventional full adder, but it is a gate number of transistor increase, also number of the delay is also increased, so that the power consumption is more. So so the industry is want to the full adder, it is a low power consumption and high speed, so that we need to reducing the number of transistor. So how we design to reduce the number of transistor. In next PPT you see that conventional full adder, that it is your 28 transistor we use in this. So and this power consumption is more, it is and delay also increases, because if you put the AVC input, that you can see that the three input, and you can see that sum and C out. So that if we give the if they give the input, so number of delay also increase, because in this circuit we using a 28 transistor. So so I want to reduce my power consumption, so also we reducing the number of transistor. You can see that how what consumption of power of the circuit. It is a power consumption is more. You can see that the average power consumption is 2.5 watts, and the maximum power consumption is 7.5 at a time. So that the power consumption is more at a circuit. You can see the waveform of full adder circuit, how we can summarize. You can see that A, B, C is a three input, and sum is out and C out. So that if we put if we put 1 0, and what we put C also 0, if we three inputs also 1 0 0, what we get the sum is 1 and C out is also 0. So that is a conventional full adder waveform diagram. So that you can see the delay is also some time delay is what 10.24 nanosecond. Somewhat delay is more, but you can later on see that the delay is less in the dynamic in the proposed full adder. So next PPT goes on the proposed full adder. In the proposed full adder, we designing the such type of full adder using the number of transistor is less by 9 transistors in this circuit is we use. So we use the XNOR or